Good morning. I am really excited to be working on brain-computer interfaces because I think this technology has the promise to restore lost abilities ranging from healthy mood and memory to communication. I think the pathway lies through these high bandwidth devices to restore communication. Let me show you what I mean. This is a man who is a participant in our clinical trial. He has ALS, and this is him trying to speak. So if you're like most people, you could not understand him. But as you can now see, he has these electronic boxes on his head that are connected to a device in his brain. And if I turn the camera around, you can see what this enables. He is trying to read that sentence at the top of the screen, and as he speaks, you'll see the BCI output words that it decodes directly from his neural activity.
Maybe after we're not in school anymore.
So here's how this works. We start by implanting 4 microelectrode arrays into his speech motor cortex. And these electrodes record the action potentials of individual neurons, so our signal-to-noise ratio is very high. We take and process the signals from these 256 electrodes and send them through a deep neural network that's been trained to output the probability of every phoneme at each time step. Those phoneme sequences are then fed through a pair of language models, which assembles them into words. And when he's done, a computer speaks that sentence out loud in a voice that replicates his pre-ALS voice. This BCI is very accurate. I'm plotting the word error rate, so the ideal is 0%. And after just a few hours of training data, we already exceeded the previous state-of-the-art. And with additional data and algorithm improvements, we were able to reduce errors tenfold to about 98% accuracy. What's also really encouraging is that this system has continued to work this well for over a year and a half now. And this has made a tremendous difference in this man's life. Here's a video of him using it for the very first time to speak with his family.
Hello, is this on? I'm looking for Cheetah.
So that was not a mistake. His 4-year-old daughter had just walked into the room dressed in a Cheeto onesie. And this was remarkable because due to his ALS, he had never had a conversation with his young daughter before. He now uses this system as his primary means of communication all day, every day. He's even been able to regain the ability to work full time. He uses this to Zoom, to make phone calls, to write emails, Slack, all of that. Okay, so what's next? Well, what I just showed you fundamentally decodes text. But as we all know, there's a lot of nuance to what we're saying and how we're saying it. And so our current big project is to directly decode his voice instantaneously. So the voice you're about to hear was generated in real time from his neural activity, and he's hearing it as he's trying to speak.
I am good. How are you?
It's not perfect yet, but we're going to get there. And because he's directly controlling the voice, he can do things like change the pitch to change a statement into a question.
Do you have?
And so I'll let our participant explain in his own words why this technology is so impactful.
People who do not have the ability to communicate well or quickly are often isolated and lonely. Having something like this will give them hope and opportunity to be more of themselves. I hope that we are at a time when everyone who is like me have the same opportunity as I do to have a device like this that will help them communicate. Let's all make that happen, okay?
And so that's what motivates me to keep making this better and to start to expand this to a wider range of patients with language disorders. Thank you.